Now the next part is properties of Laplace transform. So first is state and prove linearity property. First one, state and prove linearity property. So first we write down the statement here. So consider two time domain signals, two time domain signals x1 of t and x2 of t. If x1 of t, its Laplace is x1 of s and its Laplace is x2 of s, then a1 x1 of t plus a2 x2 of t, its Laplace transform is a1 x1 of s plus a2 x2 of s, where a1 and a2 are constant. Where a1 and a2 are constant. So now here we write down the proof. Now according to the definition of Laplace transform, xs is equal to Laplace transform of x of t. So it is minus infinity to infinity x of t e raised to minus st dt. So here x of t is equal to a1 x1 of t plus a2 x2 of t, and we can write therefore a1 x1 of t plus a2 x2 of t minus infinity to infinity a1 x1 of t plus a2 x2 of t into e raised to minus st dt. So a1 is constant, minus infinity to infinity x1 of t e raised to minus st dt plus a2 into minus infinity to infinity x2 of t e raised to minus st dt. So comparing each term of RHS, comparing each term of RHS with definition of Laplace transform, we get Laplace transform of a1 x1t plus a2 x2 of t equal to a1 x1 of s plus a2 x2 of s. Now we can write ROC for this. So ROC is resultant ROC. We write here resultant ROC is an intersection of ROC of x1 of s and x2 of s. Now what is the use of linearity property? So the use, we can express the given signal in the form of two or more elementary signal, and then by finding their individual Laplace transform and by adding them we can simplify the solution. Now what is the meaning of the linearity property? So this linearity property states that the Laplace transform of linear combination of the signals is same as the linear combination of their individual Laplace transform. So the Laplace meaning of linearity property states that Laplace transform of linear combination of signals is same as the linear combination of their individual Laplace transform, while the resultant ROC is the intersection or overlap of individual ROC. So this is the meaning of linearity property. Now next property is time shifting, that is shifting in time domain. We write here time shifting, or we can write in bracket shifting in time domain. So this property was asked in exam for multiple times, that state and prove the shifting property. So first we write down the statement, that is if x of t is input signal, if x of t is input signal whose ROC is R, then Laplace transform of x of t minus t0 e raised to minus st0 into x of s ROC is R. Now we write down the proof for this property. So it was asked for 3 or 5 marks. Okay. So from the definition of Laplace transform, we have Laplace transform of x of t is minus infinity to infinity x of t e raised to minus st dt. So Laplace transform x of t minus t0, it is minus infinity to plus infinity x of t minus t0 e raised to minus st dt. Now consider k is equal to t minus t0. Therefore, what is dk? Dk is equal to dt and t is equal to k plus t0. Therefore, Laplace transform of x of t minus t0 is, it is minus infinity to infinity x of k into e raised to minus s of k plus t0 into dk, and we can also write as e raised to minus s into t0 outside the integration as it is constant. So minus infinity to infinity x of k e raised to minus s of k into dk. Therefore Laplace of x of t minus t0, it is e raised to minus st0 x of s and its ROC is r. So what is the meaning of this time shifting property? Here x of t minus t0 indicate that the sequence xt is shifted in time domain delayed, thus shifting the signal in the time domain by t0 corresponds to multiplication by e raised to minus st0 in the frequency domain. That means it introduces a phase shift in frequency domain. This is the meaning of time shifting property. Now next is shifting in S domain. The previous was in time domain. Now the next property shifting in S domain, that is in frequency domain, or we can say frequency shifting. We write here shifting in S domain, or we can write frequency shifting. So next is, first we write down the sentence statement. If x of t, its Laplace transform is xs and ROC is r, then e raised to s0t into x of t, its Laplace transform is x of s minus s0, and ROC is r plus re of s0. Now proof for this property. So from the definition of Laplace transform, we can write Laplace of x of t, it is minus infinity to infinity x of t e raised to minus st dt. So Laplace of e raised to s0 t x of t minus infinity to infinity xt raised to minus st e raised to s0 t dt. So it is minus infinity to infinity x of t e raised to minus of s minus s0 into t dt. So we can write x of s minus s0, and ROC is r plus re of s0. So here, now what is the meaning of shifting in s domain property? Here x of s minus s0, it indicates the frequency shift by s0. Thus frequency shift by s0 is equivalent to multiplying time domain signal, that is x of t by e raised to s0 t, and ROC is also shifted by re of s0. So this is the meaning of shifting property in frequency domain and s domain. Now the next property is time scaling property. So next is time scaling property. First we write down the statement for this. If x of t, its Laplace transform is x of s and ROC is r, then Laplace transform of x of a t, it is 1 by mod of a x of s by a, with ROC r1 is r by a. Now we have to prove this property. So proof for this. From the definition of Laplace transform, Laplace of x of t, it is minus infinity to infinity x of t e raised to minus st dt. Therefore, Laplace of x of a t, it is minus infinity to infinity x of a t raised to minus ast dt. So we put at is equal to p, okay, and therefore t is equal to what? A by p, and dt is equal to what? A is constant, so sorry, it is p by a is constant, 1 by a dp. So our equation becomes Laplace transform of x of at, it becomes minus infinity to infinity x of p x of p e raised to minus s by a p into dp by a. So we simplified, it is 1 by a is constant, okay, so it is minus infinity to infinity x of p e raised to minus of s by a into p dp. Now we compare the RHS with the definition of Laplace transform. So we write here, so here comparing RHS with definition of Laplace transform. So Laplace of x of a t, it becomes 1 by a x of s by a. Similarly, we write here, similarly negative values of a we get Laplace of x of minus a t, it is 1 by a x of s by minus a. So ROC is r by minus a. So in general we can write Laplace of x of a t, it becomes 1 by mod of a x of s by a, with ROC is R1 equal to R by A. So now what is the meaning of this time scaling property? In time domain we have the term x of at. It indicates the multiplication of time with some constant a. So it is the expansion of time axis. When in frequency domain we have the term x of s by a, and it indicates a compression in frequency domain. Thus expanding time axis is equivalent to compression in frequency domain. So the ROC is also expanded or compressed depending on the value of a. This is the meaning of time scaling property. So now the next property, this is fourth one, this is fifth one. Now next is time differentiation or a differentiation in time domain. So we have to state and prove this differentiation property. First we write down the statement for this now. So if x of t, its Laplace transform is x of s, here ROC is R, then d by dt of x of t, its Laplace transform is s into x of s, and ROC is R. So we have to prove this property. We write down the proof here. For the proof of this statement, we use the definition of, we use definition of inverse Laplace. Inverse Laplace. So the inverse Laplace is x of t is equal to 1 by 2 pi j integration sigma minus j omega to sigma plus j omega x of s e raised to st ds. Okay, now differentiating both sides, this equation we differentiate both sides with respect to t. We write here differentiating both sides with respect to t. So it becomes d by dt of x of t is equal to 1 by 2 pi j integration sigma minus j omega to sigma plus j omega x of s d by dt of e raised to st ds. So we just simplified 2 pi j so it is 2 pi j into sigma minus j omega sigma plus j omega x of s into s e raised to st ds. Okay, therefore d by dt of x of t, it is equal to 1 by 2 pi j integration sigma minus j omega sigma plus j omega s into x of s e raised to st ds. So here we give the equation number, this is equation number 1 and this is equation number 2. So we compare these two equations. Right here compare equation 1 and 2. So we can conclude that by comparing we conclude that LHS of equation 2 is inverse Laplace, or we can say Laplace inverse of s into x of s. So we can write d by dt of x of t, its Laplace transform is s into x of s. Now we write down here ROC. So ROC is ROC of d by dt of x of t is contained in ROC of x of t. In ROC of x of t. So in general, we can write the result as d raised to n dt raised to n x of t. Its Laplace transform is s raised to n x of s. And ROC containing, we write here, ROC is containing R. Now what is the meaning of this time differentiation property? So the differentiating the signal in the time domain is equivalent to multiplying its Laplace transform by s in the frequency domain. This is the meaning of time differentiation property. Now next is differentiation in S domain. That is, S domain means frequency domain. Differentiation in S domain. So first we write down the statement for this property. If x of t, its Laplace transform is x of s, ROC is R, then minus t of x of t, its Laplace transform is d by dt of xs, ROC R. So now we write down the proof for this. According to definition of Laplace transform, xs is equal to minus infinity to infinity x of t e raised to minus st dt. This is equation 1. Now differentiating both sides, with respect to s. So d by ds of xs is equal to minus infinity to infinity x of t d by ds of e raised to minus st dt. So d by ds of x of s, it is minus infinity to infinity minus t x of t e raised to minus st dt. This is equation number 2. Now by comparing equation 1 and 2, we can conclude, we write here, by comparing equation 1 and 2, we conclude that the Laplace transform of minus t of x of t is equal to d by dt of x of s. That is, we can write minus t of x of t, its Laplace transform is d by ds of x of s. Now we write down ROC for this. So in this case, ROC is unchanged. We write here, in this case, ROC is unchanged. So in general we can write this result as minus t raised to n x of t. Its Laplace transform is d raised to n ds raised to n x of s, and its ROC is R. So what is the meaning of the differentiation in S domain property? The differentiating the sequence in S domain is equivalent to multiplying the sequence in time domain by minus t. So in the next lecture we will see the convolution property. Convolution property, time integration property, integration in time S domain, and Laplace transform of periodic signal. So this proof can be asked in exam for 8 marks or 4 marks.